In our first two lessons, we reviewed how to use SOHCAHTOA, or right angle trigonometry, by using the sine, cosine, and tangent ratios. We also reviewed Pythagorean's theorem, a squared plus b squared equals c squared, and labeling sides of right triangles to show the hypotenuse, the opposite, and the adjacent side in accordance to a certain reference angle. Now we're going to take this a little further beyond our last lesson of solving right triangles, which meant finding everything that is unknown. We're going to now move on to what it's called complex trig questions. Now complex usually just means that the diagram is going to be a little bit more difficult, and you might even have to do 2 steps to reach an answer as opposed to just 1. So we're going to look at this diagram here, and it's saying solve for QS, ST, and RT. So we're going to just start doing that right away. And you could see that I'm going to look for QS first simply because it was the first thing listed, and it does help us later on in the question. You can see that this diagram is actually pretty confusing, but you should be able to identify several right triangles within this diagram. So the first thing it's asking us to find is side QS. So I'm just going to outline where QS for us is, and that's right along here. So this is the side we're trying to find, QS. We could see we do have a 26-degree angle at the top, and I could just use this entire large triangle, and that's a right triangle, to find the side QS that it's asking me to identify or to calculate. So in these types of questions, I would recommend pulling out the diagram to get rid of all the lines we don't actually need. So here's that big yellow outlined triangle. So I have all this. Here's my 26 degrees up top, and I know this is 12.5 centimeters, and this is the side right here that I'm trying to find. So if I was looking at this, and we've done a lot of questions, this 26 does become my reference angle. And if that's my reference angle, this becomes my opposite side, and this becomes the adjacent. And we've practiced a lot labeling the sides of the triangles. Now, if you look just on top here, opposite and adjacent, that's my tan ratio. So I'm going to start the question by saying the tan of that reference angle, which is 26 degrees, is the opposite side divided by the adjacent side. So the tan of 26 degrees, the opposite in my diagram is that 12.5 centimeters, and the adjacent's the side I'm looking for. So I could put that as a question mark, I could write adjacent, but I'm going to put QS because that's how the question's actually identifying that side. Now again, we should know that when we're finding the side of a triangle, this is when we come down to cross multiply. So cross multiplying, we look for, if we write this X, the numbers, or sorry, 2 numbers at the end of one of those lines we drew, and those are the things we multiply. So 12.5 times 1, which 12.5 times 1 is just 12.5. So you can write the multiply by 1, or you can leave it out. And we divide by the other thing in the question, which is the tan of 26 degrees. So then again, I'm going to move over to the calculator, and I'm going to really stress that when we're in this unit for trigonometry, we have to check that we're in degree mode. So ensure that your calculator says degree or D or something to show that you're actually working in degrees. And now I'm just going to write what my steps are. 12.5 times 1 divided by the tan of 26 degrees. And when I do this, you could see that now QS turns out to be 25, and we'll round to 1 decimal place, 25.6 meters. So side length QS, we've found it. It's 25.6 meters. So now let's move on to a different part. So what I would also recommend now is just clearing up our diagram. Whoops, I guess we still need this label there. And we're going to move on to find side ST. So if I'm looking, I should identify where ST is first. ST is right along that side. And then if I try to say, okay, that's the side I want to try to figure out, I can make this into a right triangle right along here. And the reason I'm choosing this right triangle is because I just found out the distance from Q to S. I know that this side is 25.6. So now this is a right angle here. The reason that's a right angle is this whole side from S to P is 180 degrees. And if they show me that this is 90, the other side of that line also has to be a 90-degree angle to make 180. So again, I would recommend pulling out that triangle so we don't have to actually look at all the lines on there. So here's Q to S, which we just determined to be 25.6. This is S to T, which we're trying to find, and this is still 26 degrees. So we've pulled the triangle out, and we're going to look at what we need. Here's my reference angle, the 26. Now, the 25.6, oh, this is also the right angle. The 25.6 is my hypotenuse because it's across from that right angle. And this question mark, or side TS, is adjacent. So if we look at that acronym we've always been talking about, SOHCAHTOA, the adjacent and the hypotenuse side, that's cosine. So we're going to say the cosine of 26 degrees is adjacent over hypotenuse. The cosine of 26 degrees, plug in the things that we know now. I know the hypotenuse is 25.6. We just determined that. And the adjacent side is the side I'm looking for. So I'll label it ST because that's what the question's asking us to find. Again, we're finding a side and we need to cross multiply. So now we're going to multiply those two numbers because they're both at the end of one line. So I'm going to have 25.6 times the cosine of 26 degrees, all divided by now that 1, which won't make a difference to our calculations. So now in our calculator, we can look at it, 25.6 times the cosine of 26 degrees. I can divide by 1 or not, it won't change what my answer is. And side ST turns out to be 23.0 meters if we rounded to the nearest meter. So now I found the ST side. So let's go back up and read what the other part we need to find. I'm going to clear my diagram just so I can start fresh. And I'm going to say in this question, and highlight what we need to look for. We're looking for RT. So RT is across the bottom, which probably means this triangle includes RT. And if you look at this triangle that we just drew, we do know two parts of it. Or sorry, we do know, yeah, two parts. We got the 26 degrees, and we just found out that S to T was 23 meters long. So if we look, we do have enough information to find from R to T. So again, I would suggest ripping out that triangle so we don't have too much to look at. So we've got this right triangle with this being side RT that we're looking for. Still have that 26 degrees, but now we're using our last answer of 23 meters to find out the side needed. So again, our reference angle now is 26, so we can label our sides. 23 is across from that, so that's my hypotenuse. RT now is opposite my reference angle. So if I look over here, that is opposite and hypotenuse, that's sine. So we'd be saying the sine of 26 degrees is opposite over hypotenuse. The sine of 26 degrees, opposite, that's the thing I'm looking for, the question mark or RT. And the hypotenuse now is 23 meters. We have enough practice now doing this cross multiplication. We could draw this X and realize those are the two numbers that I'm going to multiply. So 23.0 multiplied by the sine of 26, all divided by 1. Now when we calculate this out, 23.0 times the sine of 26 degrees, whoops, let's start that again, 23.0 times the sine of 26 degrees, enter, and if we round to one decimal place, that gives me 10.1 meters. So complex question, start, I would pull out the diagrams without all the lines so you can see them, make them into simpler questions, and just keep true to your knowledge of sine, cosine, tangent. If you could use Pythagoras, go ahead and use it. But this will be the first part of this lesson. I'll stop it here, and there'll be a part 2 for the last 2 examples on your notes.